Imagine a sphere of plutonium no bigger than a grapefruit, holding a power so lethal that it claimed the lives of two scientists. This is the chilling history of the Demon Core. A 6.2-kilogram sphere of plutonium-239, the Demon Core was meant to be the heart of a third atomic bomb during the waning days of World War II. Its creation was a testament to the cutting-edge scientific prowess of the United States, a country in a race against time and against the world to harness the destructive power of the atom. Yet the Demon Core is perhaps most infamous not for its intended use, but for the tragedies it wrought at Los Alamos National Laboratory in the mid-40s. In two separate incidents mere months apart, the core went supercritical, bathing the lab in deadly radiation. These accidents claimed the lives of two brilliant scientists, Harry Daghlian and Louis Slotin, who were working on the core at the time of the incidents. The first accident occurred on August 21, 1945, when Daghlian, working alone, accidentally dropped a tungsten carbide brick onto the core. This set off a chain reaction, bathing the room in a lethal dose of radiation. Despite his quick thinking and immediate action to halt the reaction, Daghlian succumbed to acute radiation sickness just 25 days later. Less than a year later, on May 21, 1946, Slotin suffered a similar fate. While demonstrating a criticality experiment to a group of observers, his screwdriver slipped, causing the core to go supercritical once more. Slotin, exposed to a lethal dose of radiation, died 9 days later. These tragic accidents underscored the deadly potential of the very atoms we had sought to control. The Demon Core, a seemingly innocuous sphere of metal, had transformed into a harbinger of death in the blink of an eye, marking a dark chapter in the annals of nuclear history. Thus began the infamous journey of the Demon Core, a journey marked by tragedy and scientific breakthroughs. Born out of the Manhattan Project, the Demon Core was a testament to the cutting-edge science of its time. Its creation was steeped in a race against time, a critical part of the United States' efforts to build a stockpile of nuclear weapons during World War II. The Demon Core was a product of the nuclear reactors at the Hanford Site, Washington, a place steeped in secrecy and dedicated to the production of plutonium-239. The core's design represented significant advancements in metallurgy and nuclear physics. It was a sphere of plutonium, a notoriously difficult material to work with, crafted with precision and scientific prowess. This sphere, weighing in at 6.2 kilograms, was a symbol of the scientific progress of its time, pushing the boundaries of what was known and understood about atomic energy. The Demon Core was not just a sphere of plutonium, but a symbol of scientific progression. The name Demon Core was not an official title, but a nickname that emerged from a place of respect and fear. This moniker surfaced among the Los Alamos scientists in the aftermath of the tragic accidents. It was a chilling reflection of the core's lethal potential, a potent reminder of the lives claimed, and a symbol of the dread the core instilled. The nickname, in many ways, personified the scientists' apprehensions about the power they had unleashed. The name Demon Core encapsulated the uneasy relationship between the scientists and their creation. Witness accounts from the accidents offer a chilling perspective on the Demon Core's unleashed power. Those present during the criticality accidents described a scenario that was as surreal as it was terrifying. They spoke of a radiant blue glow, a phenomenon now known as Cherenkov radiation, which filled the room as the core went prompt critical. This wasn't a gentle glow, but a fierce, eerie luminescence that marked the release of deadly levels of radiation. Equally disturbing was the sensation of a wave of heat. It wasn't just a figment of their imagination, but a physical manifestation of the intense energy churned out by the core. This wasn't the comforting warmth of a fireplace, but an ominous surge of heat that brought with it a realization of immediate danger. These personal accounts highlight the palpable danger of the core's unleashed energy. They serve as stark reminders of the dual nature of nuclear power, a source of immense energy and potential destruction. Before the accidents, safety protocols were largely based on experiential knowledge and intuitive handling. In the pioneering days of nuclear research, scientists navigated the uncharted territory with a blend of educated guesswork and daring innovation. The Demon Core, with its lethal potential, was handled with a mix of respect, fascination, and an undercurrent of fear. Safety measures at that point were driven more by instinct than by established guidelines or procedures. Scientists relied on their personal understanding of the core's behavior, adjusting their methods as they went along. However, the accidents involving the Demon Core laid bare the stark inadequacy of these measures. They underscored the need for a more systematic approach to handling radioactive materials, one that went beyond individual intuition and experience. The tragic incident served as a severe wake-up call, highlighting the urgent necessity for more rigorous safety protocols. The Demon Corps' accidents were a harsh lesson in the need for rigorous safety protocols. The Demon Corps incidents were pivotal, not just for the lives lost, but for the lasting impacts they had on nuclear safety standards and the psychological impact on the Manhattan Project team. Following these tragic accidents, there was a dramatic shift in the handling of radioactive materials. Recognizing the inadequacy of the previous safety protocols, the scientific community undertook a comprehensive overhaul. The result was a new set of rigorous procedural controls designed to prevent any recurrence of such catastrophic events. The development of mechanical safety devices was another significant outcome. These devices were meticulously engineered to provide an added layer of protection during the handling and transportation of nuclear materials. In addition, remote handling techniques were introduced, allowing scientists to manipulate radioactive substances from a safe distance, minimizing the risk of exposure. But the changes were not confined to the physical realm. The accidents had a profound psychological impact on the Manhattan Project team. They were a chilling reminder of the lethal force they were dealing with, a force that could not be controlled once unleashed. This realization led to a shift in mindset, from one of curiosity and ambition to one of caution and respect. The consequences of this shift were far-reaching. There was a newfound emphasis on the ethical considerations surrounding nuclear research. Scientists began to question the morality of their work, wrestling with the implications of creating such destructive power. This introspection led to a greater focus on safety and the development of guidelines to ensure the ethical conduct of nuclear research. In the broader context, the Demon Corps accidents played a significant role in shaping international discourse on nuclear safety and arms control. They underscored the inherent risks associated with nuclear weapons, prompting nations to reconsider their stance on nuclear proliferation. The Demon Corps accidents left a legacy of safety and ethical considerations in nuclear research. They stand as a stark reminder of the potential dangers of nuclear power, a reminder that continues to influence the way we approach nuclear research and development today. After the accidents, the Demon Corps was not discarded. Instead, it found a place in Operation Crossroads. This operation was a series of nuclear weapon tests conducted by the United States at Bikini Atoll in mid-1946. The Demon Corps was destined to play a pivotal role in one of these tests. In the sweltering heat of July, the Demon Corps was placed at the heart of a bomb named Gilda. This bomb was detonated over the atoll, releasing a powerful shockwave and a massive fireball that mushroomed into the sky. The Demon Corps, once a silent sphere of plutonium, was consumed in the heart of this inferno. But while the Demon Corps might have been destroyed, its legacy was far from over. The accidents it caused had already sparked significant changes in nuclear safety protocols. Its final detonation served as a grim reminder of the destructive force that humanity had harnessed. In a final blaze of glory, the Demon Corps ceased to exist physically, but its historical significance lived on. The Demon Corps' legacy is not just one of tragedy, but of lessons learned and progress made. Indeed, the accidents surrounding this infamous plutonium sphere triggered a paradigm shift in the way we approach nuclear safety. In the wake of these incidents, it became abundantly clear that the existing safety protocols were woefully inadequate. This realization prompted the implementation of robust procedural controls, the development of mechanical safety devices, and the initiation of remote handling techniques for radioactive materials. The Demon Corps, in its own tragic way, catalyzed advancements in nuclear safety that continue to protect scientists and the public alike. But the lessons of the Demon Corps extended far beyond the confines of the laboratory. The accidents offered a stark demonstration of the risks associated with nuclear weapons, shaping international discourse on nuclear safety and arms control. The Demon Corps' story became a cautionary tale during the Cold War, underscoring the need for meticulous oversight and restraint in the race for nuclear supremacy. Moreover, the Demon Corps has left an indelible mark on our collective consciousness, reminding us of the immense power and potential of nuclear energy, as well as its peril. It symbolizes the double-edged sword of scientific advancement, where the same discoveries that can illuminate our understanding of the universe can also cast long shadows of destruction. The demon core, a small sphere of plutonium, left a lasting impact on the world, reminding us of the power, potential, and peril of nuclear energy. Thank you for joining us on this journey through one of history's most infamous pieces of plutonium, the demon core. Your interest and support are what fuel our dedication to uncovering these fascinating stories. If this video piqued your curiosity, opened your eyes to a new perspective, or simply entertained you, we would love to hear your thoughts. Please, leave a comment below and share this video with anyone else who might find it intriguing. And remember, we regularly post content just as captivating as the tale of the demon core. So don't forget to hit that subscribe button and ring the bell so you never miss a story. Stay curious, stay informed. Until next time, this is your faceless narrator signing off.